This is Statistical Rethinking, second edition, chapter 16, and we are on the last question of chapter 16, which is 16H5, and then there are no questions in the final chapter, which is chapter 17. So that means that this is the very last problem of the entire book. Okay, so what are we doing here? So this is the question. So we're going to revisit the Lynx Hare, Lotka-Volterra equations that we've kind of been playing with throughout this problem set for this chapter, and we are going to apply it to a different data set where we are modeling mites, and I guess that there are predator mites and prey mites. I did not know this, but I guess so. And we're going to try to fit the same model to that data set. And the point here, I believe, having read the question is, and also actually seeing how difficult the question is to complete, is not so much to fit the model to the data very well, but to recognize how difficult it can be to fit the model, and specifically to specify priors for the model. If you recall, when we were doing the Lynx Hare data set, the priors were provided for us, and now we're going to have to try to figure out what the priors are. And it's not easy. Okay, so so first we get the data set up, mites data set, which is part of the Rethinking package. It looks like this. And just to see how this looks, I'm plotting this. So we have the prey in black, and then we have the predator in red, and you can kind of see this, you know, offset undulating pattern between the two. It's not as perfect as we might hope, you know, like we have this big rise in the prey mites here without the commensurate increase in predator, or maybe we have a huge crash here in the prey, but you know, so it's not perfect, but we'll do our best. And so I'm just going to go through and try to more or less follow the steps that were laid out in the book for the Lynx Hare model, because the first thing we need to do is to establish some priors here. So this is the function, just copied and pasted from the book, although I'm relabeling it here. But this allows us to, you know, we can give some priors to this function specified here, and then we'll plot them. So so first, I'm just going to try the priors that were used, that were found to be successful for the, I shouldn't say that, the priors that were used initially in the book for the Lynx Hare data set. Okay, and it looks like this right here. And this isn't really what we want, right? What we want is, let's try to find it here. What we want, so this is way back up here in 16M3, where we applied this function. You know, what we want is, you know, these kind of alternating undulations between the two, distributions, or you know, between the two populations. And so, so in the previous example, we could have used this right here. Okay, we could have used these priors, and here I am just exploring different options, and so so I eventually got to this and got, you know, some undulating behavior here. Okay, so I'll move forward with these rather than what was found in 16M3, but you know, whatever you find and want to try is obviously okay. All right. So now we need to look at the Lynx Hare model, because we're going to need to adapt that to our data set. So you know, so to look at that model, you know, we pull it up from the Rethinking package, and we use the cat function here, can concatenate, I think it is. And that, you know, prints it out nice for us. And then we need to go through and adapt it. Okay, and so so that's what all of this is, and I'll let you look at that for yourself. I think maybe the most important part is this right here, is this new set of priors, okay, which is what we found in the prior simulation. All right. So we run this model, and it runs well enough, and then we're going to go and plot it, and we get something that looks like this. So this is not good. So right, we get one hump instead of these several undulating humps, and further, the blue lines here do not even undulate. This probably is almost certainly due to the priors, right? Which gets back to I think the emphasis of this question, which is establishing usable priors for these, for this model is not straightforward and may require some trial and error. So I think that I'll leave it there. Of course, we could continue playing with the priors, but that's just kind of an exercise in repetition. So I don't really know how much value it's going to be adding right here. So okay, we'll call that good.